Hello and welcome to the Water Research and Innovation Laboratory, located here at the SAIT campus. We hold some of the state-of-the-art infrastructure, equipment, and chemical instrumentation used to conduct accurate analytical experiments that characterize both water and soil contaminants in the environment. Our mission is to utilize inventive ideas, programs, and partnerships that work together to bring an environmentally sound, reliable, secure, and highly efficient clean energy solution into industry. The security of Canadians' water is key to our country's future. I would like to introduce you to our distillation setup here. The visual experiment I've prepared for you today shows off the hydrological cycle, with some environmental implications that can help visualize the effect of climate change. The hydrological cycle is an ongoing cyclical process that happens naturally within Earth's atmosphere, receiving solar energy from the sun. This solar energy is transferred into water molecules, allowing it to change from states from solid, liquid, and gas. The energy applied to the water molecules causes them to vibrate at different speeds. Therefore, when high amounts of energy is applied, they'll be moving very fast, resulting in the gas phase, usually done at a high temperature. As a water molecule releases energy and takes in less energy, this causes a phase shift from gas into liquid phase, or even into the solid phase. These three phases of water molecules are best known as steam, which is gas, water, which is liquid, and ice, which is a solid. The hydrological cycle works in 5 major points: evaporation, transpiration, condensation, precipitation, and percolation. In my demonstration behind me, I'm starting off the stage of evaporation and finishing off at percolation. Starting from left to right, I have a boiling flask. The color represents various amounts of minerals or heavy pollutants found in our water. This stage represents evaporation and/or transpiration. Imagine that this flask here is a source of water, like the ocean, a lake, or even trees. Here we're able to observe high energy being applied to the water, causing the water molecules to move rapidly. As the water heats up past its boiling point, it becomes steam, which is able to travel upwards as an air parcel. The following steps of the hydrological cycle are done to this interesting horizontal piece of glassware called the condensation column, which is used to simulate clouds as the moisture interacts with the wall of columns. Water molecules begin to slow down and clump together on small particulates found in the atmosphere called condensation nuclei that will form into clouds. This stage of the hydrological cycle is called condensation. As the water molecules condensate, they begin to gain weight and return back to Earth's surface through many different forms. This includes rain, mist, snow, or hail. This is known as precipitation. The final stage of the hydrological cycle is percolation, which is the action of water moving through Earth's surface. As the soil becomes saturated, it allows excess water to flow through, allowing the water to move through the surface. Remember, this is a cycle. There's no start point or end point. Therefore, water is always in constant motion through this cycle. As the world becomes more urbanized, with the expansion of cities and the ongoing use of combustion engine, we are affecting the hydrological cycle tremendously. The accumulation of greenhouse gas that we emit into the atmosphere will trap solar rays from leaving, resulting in more evaporation, which can lead to longer periods of drought. Carbon emissions are also small enough particulates in the atmosphere that make for great condensation nuclei that can increase the surface area of clouds to the point they hold so much water it can cause torrential downpour in areas, resulting in floods. As we develop larger cities, this disrupts the percolation of water through the Earth's surface, reducing the ability for aquifers to be refilled. Climate change is a real and evolving issue that needs more of the greatest and brightest minds working towards a better future. Steps can be taken in the innovation of science, technology, engineering, arts, and mathematics. So I hope you all learned something from today's video, and this is a call to action for all for the innovation of STEAM.